Hello. Today I'm going to solve an interview question in real time. I'll go to LeetCode, find a random question on here and that I've never seen before, and talk about how I would come across a solution before I start coding, describe every part of my thought process, and then code it and test it. I know there's a lot of coding interview advice online about what you should do specific things, but I feel like there's fewer examples of what actually happens as you solve one of these questions in real time. And so hopefully today this gives you one of those examples. Let's go through a question. I'm going to pick something that a lot of people have upvoted, way more than downvotes, and is maybe medium level. So this looks good. Let's see if it's, oh, this is medium, great, okay. So the question name is number of islands. Given a 2D grid map of ones, land, and zeros, water, count the number of islands. So it seems like we have a sea of zeros and we want to count the ones. An island is surrounded by water and is well formed by connecting adjacent lands horizontally and vertically. You may assume all four edges of the grid are surrounded by water. So that seems like, given the outside of this 5 by 4 box, you just assume it's all water, so the land isn't extending beyond that. So it seems like this land this is connected to this, and so this is one piece of land. So yeah, answer is 1. And this one, there's a little grid here. There's one box here, and there's one box here. That has 3. Okay, it sounds like we're just given an array, a 2D grid of presumably mostly zeros, but that doesn't have to be the case. And there are connected regions of ones on this. We want to find how many regions of ones there are. And connected here is defined by vertical or horizontally adjacent. So if it's diagonal, in this case, it does not count. Okay. Usually in problems like this, I imagine we'd have to loop through the image, the 2 by 2, or the two-dimensional array. If we were to loop through it, we can find essentially these regions. If we find any connecting regions in a row, then we know for sure they're connected. The tricky thing is if it's like a vertical list of an island, then is that connected? That is connected, but we wouldn't know until we get to the next array. But by the time we got to the next one, so by the time we got to this one, excuse me, how would we know that it's connected to a thing above? So we would only know if we actually look there. So I guess every time we see a 1, we should look above and to the left. Like, if there's a 1 above it or to the left of it, then it is part of a previous thing. It is not a new thing. I mean, I don't know if that case actually, if that criteria works for everything. In this case, if we go through 1, this is a new one there because there's nothing above or to the left of it. If we look at the next one, that is a 1, but there's a 1 to its left. Okay, next one is 0. Okay, so it seems like we're essentially counting ones where there's there is not a 1 above or to the left of it. I'm not certain that actually accurately describes the nature of this problem. I'm trying to see if there's a test case where that is not true. Because a 1 would only be connected to something else. Like, it's only part of an island if it's next to something vertically or horizontally. And if it's the first one on the left, then all the ones to the right of it will be counted later. And if there's something above it to the left of it, so there's a case that wouldn't work. So I'm going to use a tool called CoderPad. It's relatively popular in programming, especially phone screens. You can try a demo of it. You can just launch, like I did, a Chrome in incognito mode, hit demo because it only lets you have it once. Hit your preferred language that you like to hate, enter your name, and it only lasts for 30 minutes. So if you're doing the demo mode, be sure to like copy out your code and paste it back in 30 minutes later. Otherwise, they kind of kick you out. So the case I was thinking of where it wouldn't work, let me just paste in all of the examples here that I have to verify anyway. The case that wouldn't work is if somehow, oh, there it is, so 29 minutes. Let's close that. Yeah, I just have to finish this in 30 minutes. Is if they're connected like this. So we'd see the first one like this one time. And then once we go to the next row, we'll have seen the second row, the one in the second row, and there's no one above or to the left of it, but they are connected like this. And the algorithm I described would not work. Let's see how we can do this then. Seems like in this case, if we find this one, we wouldn't know if it's connected to anything else, so we keep going. If we see the second one, we think this is the first thing, but it's not. We'll keep on going to the next one. I guess it would always be linked to the first row. So if we're on the row where we think we found the first thing, and one of the ones here happens to have a 1 above it, then we know this is not the first row, because we would have seen the first thing much earlier. Right? So what I'm saying is the first top left thing has to be higher up than this row. So once we've seen this, and we saw this, we'll have to check again, is there a thing above it? Right? If there is, then we have to subtract one there. That was not a real first part of the island. Let's see if that case actually holds true, or that algorithm holds true for all cases. Are there weird things where, like, this will only happen essentially if one of the ones sticks out like that. Is it possible for somehow for these ones to be connected? I guess it could be like this. Right, so as we're iterating through this, we see this one. I think that's one. Okay, we keep on going. We see this one. We don't actually know if it's connected to the first one. We actually think this is a new one. Well, actually, we don't, because there's a thing above it. But we don't know if it's connected to this one. So we can't validate whether a one we've seen on one row is actually the first thing we've seen at the end of the row. So when we process one whole row, we cannot be certain that the first one is a new thing that we've not seen that's connected to something else before. So there's some dependency here with how rows are connected to each other. So what we want in this particular case, we went through these three ones. We're like, okay, these are all the same thing. We go through here. We would only know if this one is connected to that if we can remember this entire chain afterwards. And so here I'm kind of trying to come up with an optimal solution. I imagine there's ways to brute force it. So one way to brute force this whole thing, stepping back for a second, so trying to dig further into this hole that I might not be able to come out of, is once we see a 1, create some kind of queue so that we in-queue all of the ones around it. So there's only one around it, okay, and we process this queue and recursively in-queue everything around it until it's empty. But as part of this process, I guess for every item we're processing this queue, we want to remember that this position, so that the next time we come across, so when we come to this one, we start a queue to go all the way around like this. And once we finish this queue processing process, we go to the next one here. We want to know, oh, we already processed that. We want to mark that as previously seen. So the queue processing process is a process of marking things as seen in some global states that remembers, oh, we've processed these ones, don't ever touch them again, so we know they're not connected. And this queue process would find all of the ones. I guess it has to access that global state as well, because by the time we get to the third one, we want to make sure we don't want to in-queue this thing on the left, because we just processed that too. So this kind of feeds onto itself. One concern I have now is how performant is this? If we're going through every element in this whole image, this whole rectangle, every pixel in this rectangle, and we're doing some kind of like this flooding behavior to figure out everything that could possibly be around it, is that like in whatever polynomial? That could be bad. But I don't think it is, because for every one of these we check, we go all the way around it, we figure out what it is. But for the next one, we won't actually do this again, so we just skip it. So essentially for every island, we visit it a max of 2 times. The first time is when we do the initial iteration through this rectangle. We go through every one. And the second time is possibly it got in-queued as part of this queuing process. Okay, so this seems pretty fleshed out in my mind. The time complexity seems like it's order O of n, and being the number of pixels given, so that's the width times height. Space is probably because the queue actually goes all the way around it, but that's constant because there's only 4 sides I want to look at. But there is this global state I want to keep track of. If it was all ones, I would somehow keep track of that. So the state is probably O of n as well in the worst case, because in the worst case, if all ones, this map of a sort would have as many pixels as the size of this rectangle. And when I say map, I do mean map. So because the data structure I'm looking for here is, okay, so operation I want to be able to have execute quickly on this variable, this state is given a coordinate. I want to look up quickly whether or not I have previously seen this, whether or not I have marked this. And the coordinate can be encoded with like x and y. And so this sounds like what a dictionary or map is used for. I'm using JavaScript here. It's as crappy as any other thing. So, let's start this thing. So first, I'll have to write some sample inputs. Let's just say, what was the terminology by this? Grid map. Okay, grid 1. So it probably wants this. Wow, this is terrible. I'm going to turn on Vim mode here so I can do this quicker. This worked great. If you're not using Vim, you should at least try to learn it or give up after you try it. But one of the cool things is it's got macros. So I can do things like record a macro for this line, put 2 spaces, do that, comma, 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 that, go to the next line, and finish recording macro. And now I can replay this macro. So that's really cool. So I know this is great use of your time and mine. It's weird that it doesn't backspace properly. Yeah, get used to your coding editors, complain and fix it if it's not right. Okay. Oh, it all completes too. That's cool. So the function I want to write is what are we trying to do here? Never mind. Okay. Find Iceland counts in grid. And it's usually a good idea to write a function that takes an input and gives you something you want and then print it out after. Yay, Vim. Okay. It did all this and it printed out nothing because I didn't actually print out anything. Awesome. So time check, I started at 6:04. It's 10 minutes in. And I think describing this is helpful, especially in an interview for yourself, just to talk out loud. So this is undefined because this function doesn't return anything. So what I said earlier that I would, ES6 by the way, if you're writing JavaScript, you should try looking at ES6. It'll make your life easier. Have a variable of scene map, or map of, let's call it grid of scene pixels. Let's just call it scene grid. And this will have the key will be getting encoded of x plus y, and there needs to be something to separate the two. So like a space. And the value is true if it's in there. So we'll iterate through the whole grid. There's a row. For each row, what are we calling it? Like pixel item. Ooh, then bindings. So if the algorithm described before is if this pixel is previously seen, do nothing with it. If it's 0, do nothing with it. If it's a 1 that we haven't seen before, then yes, this is the start of a grid and we're going to start marking this thing. But to mark it, we need the coordinates so we can access it much quicker later. So we actually need the index for this, row index. Column index. And here I'm just assuming that this input is well formed. You're not going to have like one row that's longer than another. So if so let's say key is maybe a will help with actually it's fine. Row idx plus space, and I know the JavaScript conversion rules from integers to strings, so this should work. That's always a source of pain. If scene grid key is true, continue. If scene grid, or rather if pixel is 0, am I trying to find ones or zeros? Ones. Okay. Yeah. Okay. Once. 0 is water. If it's 0, if it's water, then do nothing with it. Okay. Continue. Of course, that's else if. Otherwise, this is actually where it is. I'll clean this up later because it continues. This makes this look. It's not actually doing anything. But I'll console log just to make sure that I'm approximately doing the right thing here. Continue. Oh, that's right, because this is a function. It's not a for loop. It's a callback. So just nothing. Oh, even more reason to remove those cases. Great. So in the first one, the first 0 is the row 0. The index of column is 0. That's not right. Maybe I should do this, and then I just want to verify that the base part of this is right. Otherwise, when I build on it, it'll be hard to debug later. Set this. 0, 0 is pixel 1. That's not true at all. What is pixel? What do you think pixel is here? You think pixel is, if pixel is 0, oh no, that's hold right. Okay, so I actually want, if it's a 0, do nothing. If it's a 1, oh yeah, okay. Oh my god, I keep on thinking 0 is line. Okay, no, that was right. So do nothing there. Pixel of 1. Yeah, this is the first 0. I see. Okay, that's what I was confused. Because 0, 0 is the coordinate of an island, and then 0, 1, 0, 2, 0, 3, 0, 4, 0. Oh, that's not right. Oh, because I printed the. This is awesome. Live debugging is not pressure at all. 0, 0, 0, 1. Okay, 0, 1, 2, 3, because there's 4 of those. Right, and then the next set is row 1, 0, 1, and then 1, 3, because off by 1. Okay, great. So I have the cases where I found all the 1s. So when this is true, I want to create a queue. Queues are just lists. I want to enqueue all of the 1s around this pixel, so up, below, left, right, into this queue, as long as it's not in the scene grid. So, and I guess there's some boundary conditions here. If it's in the first row of this whole image, I don't want to, I don't want to put in what's above that because that'll go out of the index. So if row IDX is bigger than 0, yes, then I'll look at the top thing. If column IDX is bigger than 0, which means it's at least 1, then I'll look at the this thing, left thing. If column IDX is less than, I should establish the width of this thing. Row count is grid length, and I'm going to assume that there's at least 1 pixel in this so that we don't overflow here. Grid. So the first row dot length. So I have this clear. If the column IDX is less than the column count, all these off by 1s. So if column count is 5, there's 5 things. That means if column IDX is 4, then which is the last index of the column, or the index of the last column, I do not want to push this in. So it has to be less than the column minus 1. So if that was 5, this is 4. 4 is not less than 4. Great. Okay. This is right. And row has something similar, I'm gonna guess. So if yeah, it's exactly the same. So let's do the enqueuing. And of course, is there any other boundary conditions if I try to index? It should be okay. So scene grid. The key for this would be row IDX. This is getting harder to read because I have a small screen here for the sake of this video. Row IDX plus call IDX. So this should be row IDX minus 1. Thanks to the magic of casting. This does not do some weird string conversion and math, hopefully. So if I haven't seen it, then enqueue it. Q.push. I actually want the coordinate of this. So row IDX, call IDX. This is ES6 syntax for make a map with this key and the value of this local variable. Except that should be minus 1, so we can't do that. That's fine. This is looking like a lot of code. Now I'm trying to think if there's ways to make this not as a lot of code. So the left thing is the row stays the same. The column with -1. I'll do all of these first. The right and oh, I totally screwed that up. The condition is messed up. Yeah, we perfectly well thought out conditions. This is what I had. Row +1 plus column ID. And this should be +1 because it's to the right. I'll have to double check these later. I'm just going pretty blind here. +1. Row stays the same here. Call IDX -1. +1. Okay. I'm going to check all these later. So this does one queue. I actually want to do this recursively for every item in the queue. So what I want to do is essentially row IDX, call IDX, and while queue is not empty, queue length is not 0. I want to dequeue this thing. It doesn't actually matter where I start from because the map makes sure things don't get enqueued more than needed. Let's pop item, or rather pixel to process is pop, and I want to do all this good stuff in there. So I'll indent this. This establishes the queue. It does not yet mark it as scene. So once I push into the queue, I have to mark it as scene. Grid. I guess I already know the row. I'll write this out. So row IDX. In case you're not familiar with JavaScript, it'll just look like shenanigans. Oh, that all completes. That's nice. So this is the row and column indices we want to do, and the key for those is like this: space pixel column IDX is true. So this is the only time we're actually writing to the scene grid. We're not writing this anywhere else. We're checking it a lot of places, but we're only writing it here. And after we've written it, that's actually all we need to do. That's why we're here to process. This is what we're here to process. And then we figure out everything around it. We push it into the queue. Actually, I don't remember if I thought about or talked about. I don't know how many islands there are. Got so caught up counting pixels in an island. Okay, so there's you know there's an island if you're at this state, right? Because this condition would have kept us out of previously seen subsections of islands. This one is water, so when we get here, we know that this is an island. And when we know it's a new island, we just have to process everything to make sure that later we don't look at it again. Okay, let's clean this up a little bit. So I want to get rid of these conditions that seem silly. So essentially, if I haven't seen this before, and pixel is 1. Okay. This looks a little messy because we're already inside like 2 for loops, an if condition. I can make this look better by going if we have seen the pixel or pixel is 0, then just early return. So we lose at least 1 level of indentation. That makes it easier to see. I think there's 2 of these. Okay. This makes the code clear to see that what we don't care about is not as important as what we do care about. This is what we're trying to do, and if we don't have the stuff we don't care about, then just ignore it. So this is mostly it. Let's run this and see what happens. Probably terrible things. Yep, of course. On line 44. I made this a const. Const means don't change it. The reason this is a const, JavaScript oddities, is, and I can change it, is because maps. I can't change what the map is that scene grid variable references, but I can change what's inside the map. Okay. So that's definitely not 6, right? First grid is first. The first one should be 1. The second one should be 3. It's totally not right. So let's debug it. Let's figure out when we're actually here. Actually, how many pixels are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're getting rid of some of these. And to make this clear, I'll only work on the first one. So we think that these are new islands when we do something like first, this one we think is a new island. This one we think is a new island. This one. Everything on the first row. This one and this one. I feel like I'm not enqueuing stuff properly, like stuff to the right or the left, because it seems like this one got it, and these two got it somehow. So I want to check to see like what is being enqueued. I essentially want to print the queue at the end of, maybe at the start. Well, I know this is incorrectly being queued. So when we get to, actually what's better is, so the earliest point where there's failure in the code is this pixel is getting enqueued incorrectly. It should not have been. That code happened here to the right. It's here. Or rather, it got enqueued, but the map did not get marked correctly. So to narrow down this case, like so I don't have garbage output. Let's look at this. So in this case, the island should just be 1. Right, and here we get 2. So when we're here, we can only be possibly here because of the first one. Are we actually here? We're not actually here. Oh, that's right, because it's this one. Should have left the comments in here. So this is bad. Where we think it should be isn't. So we're not actually queuing any of these at all, which is what should happen. So let's figure out if like what are all the things we've ever enqueued. We've enqueued the first one. Oh god. Oh, that's not good. Okay, let me see if I can save some of this. This is terrible. I mean, it's great product, but it sucks when this happens. Just delete it. Is there more here? Okay, I'm just gonna copy the code, which I can't do for some reason. I'm just thinking. And then I'll close out of both of these. Relaunch it. Oh yeah, that's right. Can't do that's the code. Okay. All right. We're back in business. Where was I? When I was looking at the first thing, the thing that was pushed in is 0, 0. Why did we ever push in 1, 0? That is not a 1. It's like we pushed the thing below it. Oh, I see. Oh, right. It actually needs to be a 1. What am I doing? Grid row IDX. All right, not bin mode anymore. This one, and call IDX is 1. There it is. This one, I'll do the last one first. I should have done like up, down, and left, right. Totally should have left the comments in the system. Top. This is ridiculous. So for the left thing, I want the same row minus 1 plus 1. Did I not call it grid? I think I forgot an ampersand there. Okay, so we're actually not enqueuing wrong things. That's good. But we're not marking the same properly here. Why did we not enqueue this one? Did we just not do any of this? I want to check every value in here to see why it's not doing that condition. I think it'll run twice. False, true, true. So the first thing is false. Call IDX is 0. Column count is like 5 minus 1. Oh, that should be less than. Good times. Good times. Yeah, so yeah, this one is mirrors that. It should be less than. There, so the answer for that is correct. Now, it's not including the wrong things. Let's get rid of these console logs. Okay, that's the only thing. Nope. 5, that's not right. Come on. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's closer. So I want to do the same debugging, but that was it's a lot of, like, there's 4 conditions here, and I want to do all of that. So maybe what I want to do is just check the state of the queue at the end of each process. So and I'll figure out what I want to know, like, which one it is, so because there will be a lot of these. It seems like it's cutting it off. So for the first one, our queue has the one item to the right. I don't even see a row. Something's totally cut off here. I'll make this a little smaller just temporarily to be able to see all this output. So for our first one, it's the one to the right and the one to the bottom. And that is the expected behavior. Because one to the right, one to the bottom. Okay. For the second one, which we're processing, we started with one to the bottom first. At the end of that loop, we have the one to the right, which we first had, okay, and then the one to its right. No, we actually have this one twice. We should not have that twice. Ah, I see. We have it twice because we didn't mark it yet. We shouldn't even push that in because that is not to the top or to the right of the second pixel. When we're here, why does this come up? Okay. Let's go back to the original size. So we're processing this. Let's log this out. Good old-fashioned console log. So now I just want to verify that we're actually doing all the operations we thought we are. Left, right, bottom. So for the first thing, we pushed right and bottom. Great. For the second thing, we pushed to the right. That's good. At least if condition is right. For the second thing, which was this, we pushed to the right. We should push the one to the bottom too, which we did not do. The bottom condition messed up too. What was the thing we did where we console logged the whole thing to figure out why it didn't go in? Pardon the alignment here. Oh, that's right. This is why alignment's weird. Check that over. So that's the first one, and this is the second one. We're pushing right. I'm trying to figure out if we should push left. Or we should push bottom. But it's marked as seen. The second one says, which is this line, it's been seen. Who marked that as seen? That's awful. So I think at this point I want to verify that the scene grid is correct. Is what I expect. So the first time I have this, where's my scene grid? Oh, it's empty. Okay. the second time, so I'm looking at the one right below the top left, the sync grid has 0, 0 is true. Great. So then why is that false? By the time I got to this condition, the sync grid only has 0, 0 to be true. Maybe it's the negation. So this would be false. This would be true, right? I'm just like not sure now of what is what anymore. Is that one extra? Okay. So the first item is true, great. That is 1, 0, great. Sync grid marked it as true. That's not good. So somebody said my item was seen before it should have been. So does this mark it as seen? That is not good at all. Is that the only place that sync grid is being marked? Yeah, it seems like it. Who is doing this business? We have a first one. Who? One, 0 is marked as seen because that is the item below the first one. Okay. Oh, I was actually trying to see why the... Oh. I've been using the wrong row IDs. Yeah, this would have been totally better moved out into a separate function to not clutter the namespace. So what I wanted to use was this, but what I ended up using was this. But that I really didn't want to care about. So what I'll do is the right thing now and move it into its own function. I'll pass in the map. What should I call this operation? It's like flood fill mark scene. I go through the queue. So the mapping passed in here will actually be modified as part of this process. And what's awesome about having this new function is if I run this now, it'll error out because it's using variables not in its scope. Yeah, so lesson of the day is write clean code the first time around so you don't shoot yourself in the foot so much later. I don't have to return anything because it modifies it in place. I'll just comment these out. I probably want to keep this as a sanity check. Ah, that's right. I need to pass that in. CMap is not defined on line 52. Sync grid. That's right. Here was the original problem we had. So got rid of these. The whole world would be better. row IDX is not defined on line 61. Oh, I need a starting point here. Starting point. Oh wow, 2 mistakes at the same time. That's amazing. Call counts. That's right. Let's pass in there. What do you want from me? Grid. Oh, I need the whole grid, so why even pass in this whole thing? Alright. Great, that returned 1. Oh my god. There's still a lot of console logs. Where is that happening at? Okay. Okay, so the first thing was 1 island, okay. This thing is 1 island, great. This is 3. This was 1. Great, that was the weird cases. That was 1. Awesome. So let's test a little bit. Okay, great. This is, I just removed these to remove the noise. That should be 0. Good, good. So the boundary conditions are here, pretty literal boundary. Yeah, so the cases that's weird is horizontal ones, vertical ones. How many is that? That's 4. Okay, 4. Good. Ones where that are some extreme in nature. 1, 2. Okay. Okay, that actually looks pretty decent. I'm not going to submit this back to Elite Code and justify what I did wrong. But it's cleaned us up a little bit. Whew. Yeah, a little bit. That's always fun. Yeah, this looks a lot cleaner now, having this separate. There's, as you can see, clean code actually makes a difference. This helps you debug, it helps you make fewer errors, even without other people involved, just for yourself. And that took a total of like 45 minutes for a medium question. I think a large part, like a good 10-15 minutes, was wasted on the source cause of which is this part of code not being factored out and reusing variables it shouldn't have been. I had assumed that once I read the right code brilliantly the first time, I could refactor that out, but it does not seem like that was a good strategy. So hopefully this provides some insight into at least the flow of doing one of these, like how somebody else does it in real time, not having seen a question before, how to debug it. A lot of the interviews, interview questions might happen on a whiteboard, in which case none of this would apply, and you'd have to rely more on interviewer feedback. And it's possible the interviewer doesn't actually see the bugs. Like in this case, we could have just maybe gone through. But if they saw it, they'd be like, okay, does this? I mean, they might give specific test cases and ask you to run it through. And so here we're not exercising that part of the muscle of stepping through code manually, figuring out what the state is at every point in time. There's actually quite a bit of code here. I'm not entirely happy with this. I don't know how else to like shorten this part yet, but this is just a lot of code, and having a lot of code means you can mess up a lot. I messed up a lot of the times. It might be easier to debug, but it's just time you really don't want to spend debugging. That's all. Hope this was useful.